Hello guys, in this video I'm gonna solve question 13 till 21. Which type of solute is present in aqueous solution predominantly as hydrated ion rather than as molecules? The meaning of this question is we have some keywords. The first keyword is predominantly. It means mainly. Most of the solute exists as ion, not as molecule. So weak electrolyte, no, partially dissociate and ionize, they mostly exist as non-ionized or non-dissociated molecules. Strong electrolytes, yes, all of the strong electrolytes, they dissociate completely and ionize completely to form ions rather than molecules. So B is the correct answer. A non-electrolyte, no. A covalent electrolyte, it's also incorrect. Which solute is present in aqueous solution mostly as molecules rather than as ions? So this is just the opposite of 13. It said present mostly, predominantly as molecules, not as ion. So the weak electrolytes are the correct answer because they present in aqueous solution as non-ionized or non-dissociated molecules rather than as ions. Question 15, non-volatile solutes. Of course, whenever we add a non-volatile solute into the aqueous solution, they elevate boiling point and osmotic pressure, and they depress vapor pressure and freezing point. So according to the relation between molality and the colligative properties, we would be able to answer the question. Depresses freezing point and elevate boiling point, yes, it's correct. Elevates freezing point, no. Depress the freezing point. Depress both, no. Just depress freezing point, elevate boiling point. Elevate both, no. Elevate just boiling point and depress the freezing point. What's the actual freezing point depression of 0.020 molal aqueous NaCl solution when the Kf is given? Guys, in order to solve this question, it's the keyword here is actual. We will be discussing about this when we're back to school, but shortly let me tell you what it means by the actual. For the electrolytes, there will be differences between actual and expected values between the value actual which performed by experiments in lab and expected which we calculate theoretically in the school. Why? Because as the electrolytes they produce ions, there will be attraction force between the ions. The ions they back to each other, they attract to each, and then there will be differences between actual and expected values. It's stated freezing point depression, so delta TF. Of course, we have 7 quantities. 5 of them they are directly changing with the molality, 2 of them are inversely. And those 5, the actual point is always lower than the expected pointers. And the 2, freezing point and vapor pressure, they're actual higher than the expected. So, of course, we have to calculate delta TF theoretically, and because delta TF is among the 5th quantities, the actual value must be less than the expected. So how to calculate the delta TF? Of course, by multiplying the delta TF here is equal to the Kf multiply the molality, and of course multiply the ion factor because it's electrolyte. So the difference between electrolyte and non-electrolyte is this ion factor. Ion factor, it means per one formula unit that salt or acid or base produce how many ions. For example, the salt is NaCl here, it produces 2 ions. So the ion factor of NaCl is 2. So multiply the 2 by the molality, which is 0.02 by minus 1.86. You'll get the value of minus 0.0744 Celsius. So guys, in order to solve for the actual value, as I told you, we have to state that the actual delta TF is less than that value which we calculated. So A is the correct answer, which is slightly less than minus 0.0744. But if it's freezing point on vapor pressure, we have to choose C because slightly more than that we have calculated. Compare it with 0.01 molar sugar solution, 0.01 molar MgCO2 solution has. Guys, sugar is non-electrolyte, so the non-electrolytes, they do not form ions and their factor is 1. But the MgCO2 is an electrolyte and it produces 1 Mg positive 2 and with 2 Cl negative. So 1 plus 2, it produces 3 ions. They have the same concentrations. So the factor of the effect of MgCl2 based on the ion factor, it's 3 times as the sugar because the ion factor of MgCl2 is 3 and the factor of the sugar is 1. So about 3 times the freezing point depression. So solution has about 3 times the triple the freezing point depression as the sugar. Question 18, it's also about the actual and expected compared with the actual freezing point depression. So delta TF is among the fifth quantities. So for a solution of an electrolyte that dissociates into positive 2 and negative 2 ions, a salt that has positive 2 and negative 2, like MgSO4 for example. This is positive 2 and the SO4 is negative 2. The freezing point depression for an equally concentration. So here we have to know that the concentrations are equal of an electrolyte that dissociates into positive 1 and negative 1 ion is likely to. So the following options is for the positive 1 and negative 2, compare it to the positive 2 and negative 2. Like for example here NaCl. Guys, in chemistry, whenever the concentrations in colligative property are equal, we have to pass into another level of charges, the ions. The ions with having higher charges, the higher ions, they attract more. So the charges with the lower ions, the lower ion charge, they attract less than the higher charges. So the effect of the positive one and negative one must be more than the effect of positive 2 and negative 2 because we have a term of ion effective, the existing ions. So as the attraction between the ions becomes more, the ion effective decreases. So the attraction between the ions in NgSO4 is much than NaCl, and the ion effective in solution of MgSO4 is less than the ion factor in the NaCl. So I would like to show you by a plot to understand the in detail. Let me show you the plot. Suppose that we expected both solution, they have the same concentration and their freezing point is -2. Okay, as the freezing point is -2, so delta TF for both solution must be lower than the delta TF of the expected. Here we have delta TF expected, expected. So guys, in order to find the delta TF, actual delta TF, the freezing point must be higher than the expected freezing point. So we have to choose 2 pointers for each solution above the expected freezing point, because as we approach toward zero, the freezing point becomes higher. The We will discuss in detail about this. Those that they have lower charges, there will be lower difference between actual and expected. So NaCl should be the one which is close to the expected, and MgSO4 should be the one that's a little bit farther from the expected. So in order to calculate the delta TF, actually we have to draw the delta TF. As I told you, the delta TF of both actually lower than the delta TF of the expected. These two in pink are the delta TF of each solution. So imagine, and you can notice that the delta TF of the NaCl compared to MgSO4 is greater, is higher than the MgSO4, but the freezing point of MgSO4 is higher than the freezing point of NaCl. So the C is the correct answer here. The positive one and negative one compared to positive 2 and negative 2, they have a greater actual freezing point depression. Question 19. As electrolyte concentration decreases, freezing point depression. So guys, it's still this we haven't studied, but let me provide a little bit explanation for this. Whenever the concentration increase, there will be in electrolyte solutions. Whenever the concentration increase, there will be a higher distance between expected and actual. But when the concentration decreases, there will be a shorter distance between the actual and expected. So here it's stated that when the concentration decreases, freezing point depression, delta TF, must approach toward the calculated. Here the term of the value calculated by assuming complete ionization, we mean the expected values, because we assume it's 100% ionized, but in reality, because of having attraction between the ions, there will not be such values in actual. So A is the correct answer because it approaches the value calculated by assuming complete ionization. Because as I told you, whenever the concentration decreases, the actual approaches toward the expected values. Which of the following compounds would be most effective in lowering the melting point of ice on roads? Guys, melting point is the same as the freezing point because the water melts at 0 Celsius, and also its critical point of 0, and freezes at 0 as well. So which of the option has the higher ion factor that decrease that salt would decrease the freezing point more? So the first one has the ion factor of 3, the second one 2, the third 4, and the fifth 3. So C is the correct answer because it has the highest ion factor And of course, in this such questions, the molality must be the same and Kf as well the same. You get the highest uh, depression. I mean, you get the more effective in lowering the freezing point of the ice on roads. Question number 21. When an ionic solid dissolves in water, an ionic solid, so like salts or strong bases, which of the following does not occur? So the compound dissociates, it occurs. Of course, it's incorrect. Hydration occurs, yes, hydration occurs because whenever there will be ions through the, whether it's through the ionic or through the molecular compounds, the water can attract to those ions and there will be hydrations. The compound ionizes, no, the compound does not ionize, also here said does not occur, so the C is the correct answer. Thank you for the attention, guys.